Grade 12 pre-calc, 6.3 special angles and trig functions. So what we're talking about in this lesson is we are going to basically look at a unit circle, and we're going to fill it in with information we know, but we're going to put in radians. So now in grade 11, we talked about, well, how do you find out a unit circle? We've done this before. For instance, if you have like an angle that's 45 degrees, what you can do is you can, X and Y are exactly the same. The legs on this triangle are the same. So we can call them as one. So we do all the math related to Pythagorean theorem. We find out the X value is 1 over root of 2. We rationalize the denominator. So root of 2 over 2. So sine of 45 is root of 2 over 2. Cosine is root of 2 over 2. And the tangent, since it's y over x, is these divided by, well, root of 2 over 2 divided by root of 2 over 2 is 1. And then we do the same thing for 30 and 60. We break down it. We break down the triangle. We use Pythagorean theorem. We find out, yeah, the sine of 30 is a half. The cosine of 30 is root of 3 over 2. And then if you look, cosine of 60 is a half. Sine of 60 is root of 3 over 2. Now, this is useful to know when we're setting up our unit circle. Okay, so go to the second page and look at this unit circle. Now, this unit circle has already been filled in, but what I'm going to show you is I'm going to show you a method on figuring out how to do this. So first thing you can do is if you put all your lines on here, you can label all your degrees, right? 0, 30, 45, 60, 90. So there's our basic degrees in quadrant 1. And then we just keep going around quadrant 2, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. That's all the way around the unit circle. Now we can start putting on some points. So you think about this. This is a unit circle. So the radius, so the distance from the origin here, the center, out to 0 degrees is a distance of 1. So if you look, x is 1. What's our y value? 0. So for instance, if I got you to get a calculator and I said, okay, what's the cosine of 0 degrees? And you punched in your calculator, you're going to get 1. What if I asked you for the sine of 0 degrees? You're going to get 0. Okay, so then we can keep working our way around. We can talk about 9. Let's actually talk about 90 first. So 90, right? Cosine doesn't go anywhere, and y is that one. So we put in this one, we put in the cosine of 90, we're going to get 0. We put in the sine of 90, we're going to get 1. Now, what happens if you put in the tangent? Well, think about back at 0 here, 0 degrees. Tangent is y over x, so 0 divided by 1. That's just 0. So if you put the tan of 0 degrees in, you're going to get an answer of 0. But what if you put the tan of 90 degrees in your calculator? Well, you're going to get an error. It's undefined because it's 1 over 0, which is undefined. Okay, we can keep going around 180, right? Negative 1, 0, 270, 0, negative 1, and then back again to 360. Okay, that's the basic for those ones. Now we can start breaking down the other angles. So we got 30, 45, and 60. Let's do 45 first, because 45 we figured out on the previous page, right? 45, the x and y values are root of 2 over 2. So there's our x and y. So the cosine of 45, root of 2 over 2. Sine of 45 is root of 2 over 2. Now we go into quadrant 2. The numbers are the same. The only difference is the signs. Because we're in quadrant 2, cosine's negative, y is still positive. Go down to 225. They're both negative. Go to 315. X is positive, y is negative. Now, let's talk about tan. Tan's kind of cool on this one. Tan is y over x. So back up here at 45, we have this root of 2 over 2 divided by root of 2 over 2. That's 1. So the tan of 45 is 1. We go to 135. What do you think the tan is going to be? Negative 1. What about down here in 225? That divided by, oh, positive 1. Negative divided by negative. What about over here for 315? Negative 1. Okay, those are pretty easy. Okay, now, 30s and 60s. 30s and 60s are really easy to remember. If you just look at the triangle, now just think of this, and I'll just draw it in here. I'll erase it in a second. If you think of this, there's our right angle triangle, right? There's 30 degrees. Now, if you look, which is longer, the x or the y? Oh, the x is longer. Okay, well, look at the coordinates here. Which one's the bigger value, right? Root of 3 over 2, 0.86, right? And the half, 0.5. Well, the x is bigger, right? So, right, then we know that's our x value and that's our y value. Okay, what happens to 60? Well, if we drew the triangle at 60 up here, you can see that the x value is quite a bit smaller than the y value. So they're just reversed around. So x is a half, and then y is root of 3 over 2. Then the pattern continues all the way around in quadrant 2. Use the same numbers. The only difference is the positive and negatives. You got to make sure your negatives in quadrant 2, or sorry, your x values in quadrant 2 are negative. Here, both the x's and the y's are negative, and in quadrant 4, only the y's are negatives. Okay, so that should take care of the basic unit circle. Now, here's the tricky part. And if you can figure out the pattern, it's really easy. So let's talk about radians. We already did the radians before. 0 radians, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so let's break these down. So let's start with 0 and pi over 2. So that distance right there, 90 degrees, is pi over 2. Well, what's half of that? We'll take pi over 2 and divide it by 2. Oh, that's pi over 4. Oh, okay, so from 0 to 45 is pi over 4. Okay, now you keep that pattern going. So that's 1 pi over 4. And we add another pi over 4 to it. That's 2 pi over 4. And if you reduce that down, that's pi over 2. Keep going. 3 pi over 4, right? Oh, there it is there. It doesn't reduce down. 4 pi over 4, which reduces down to pi. 5 pi over 4, because we're just keep going up. We're just counting up. Every time it's a pi over 4. That doesn't reduce down. This one here at 270 would be 6 pi over 4, which reduces down to 3 pi over 2. Go over here, 7 pi over 4, doesn't reduce down, and then back to 8 pi over 4, which is pi over 2. That's a pretty easy way to remember the 45, right? Every step around is a pi over 4, pi over 4, pi over 4 all the way around. Okay. Now, let's go back and figure out these 30s and 60s. Oh boy. So 0 to 90 is pi over 2. And we're going to break this down into 3 parts. So what we do is we take pi over 2 and divide it by 3. Well, what do we get? We end up with pi over 6. So every step here of 30 degrees is going to be a pi over 6, right? And every time we move 30 degrees, it's another pi over 6, another pi over 6, another pi over 6. So let's use that to help us figure out the radians. Okay, so 30 degrees, pi over 6. There's one of them. So from 30, we go up to 60. There's another pi over 6. So that's 2 pi over 6. 2 pi over 6, which reduces down to pi over 3. Okay, another step here, 3 pi over 6, which reduces down to pi over 2. 4 pi over 6, which reduces down to 2 pi over 3. 5 pi over 6, that's already in reduced form, it can't go anywhere. 6 pi over 6, oh yeah, that reduces down to pi. You see how this is working? We're taking a step of pi over 6 every time. 7 pi over 6, that one's fine. 8 pi over 6, that reduces down to 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6, oh yeah, that one doesn't reduce. And then back to the beginning again, 12 pi over 6, which is 2 pi. You see how that works? So in this case, right, when you're trying to create your unit circle, do your main ones, do your 0, 90, 180, right, 270, 360 with radians. Then do your 45s, because that's just basically pi over 4s all the way around. And then do your 30 and just go up by 30 all the way around. Go pi over 6, pi over 6, pi over 6 all the way around. And then just reduce it down. Okay. So flip to the last page and let's look at some examples that how it relates to this. So what we're talking about is we want to give exact values for each of those ones when we do that. So let's look at cosine of pi over 6. And what we're looking for is this means find the x value at pi over 6. So go back to unit circle. Go to pi over 6. Pi over 6, where's pi over 6? There it is right there. Pi over 6. We have our x and our y. We want the cosine, so we want the x value. So it's root of 3 over 2. So if somebody asks you for the exact value of pi over 6, you can say root of 3 over 2. And those are the main ones we're dealing with, okay? So there's pi over 3. Okay, what about cosine of negative pi over 6? Now, remember, negative, positive is counterclockwise. Negative is clockwise. So let's go back here. So we're trying to find the cosine of negative pi over 6. So we start at initial arm. We go back pi over 6, which is right here, right? So we get up to 11 pi over 6, and we look at the cosine, root of 3 over 2. Oh, it's exactly the same. Another way to do it is you could do 2 pi, which is 12 pi over 6, right? They're the equivalent one. Take away 11 pi over 6 and end up with 11 pi over 6. So the negative, what we did is we turned it into a positive, and then you can find it. Okay, what about tangent? Tangent is y over x. So tangent of 240, and this is degrees, it's not radians. Tan of 240 is sine of 240 over the cosine of 240. Okay, so let's look up 240. So 240 degrees, 240 degrees right here. Our cosine is negative 1/2, and our sine is negative 3, root of 3 over 2. Okay? So we end up with negative root of 3 over 2 divided by negative a half. Negative divided by negative is positive. Multiplied by the reciprocal, the 2's reduced down, you end up with just root of 3. So when up to this point, we've had sine, cosine, and tangent. Well, in grade 12, we're dealing with this. Each trig ratio also has a reciprocal, and reciprocal means you just flip it, right? Numerator, denominator. So cosecant is just 1 over sine. Okay, secant is 1 over cosine, and cotangent is 1 over tangent. And another way to think about that is cotangent. If you think about tangent as sine over cosine, cotangent can also be cosine over sine. I think I threw that, yeah, there, I threw it down the bottom there. Tangent is sine over cosine, cotangent is cosine over sine. Okay, so let's do an example in this case. Let's find the secant of 5 pi over 3. Okay, well, what is secant? It's 1 over cos. So that means technically we're looking for 1 over cos of 5 pi over 3. Okay, now 5 pi over 3. We're looking for the x value of 5 pi over 3. So we go back here. Where is 5 pi over 3? It's got to be on here someplace, right? And as you start to use this, you'll realize, oh, where everything is. So there's 5 pi over 3. Cosine, right? We want a half, right? So there it is. It's, whoops, it's 1 over a half. Well, we don't leave in that form. That's 1 times 2 over 1, right? Multiplied by the reciprocal, we end up with just 2. So when you get a question like this, work through, first off, change secant to cosine, right? 1 over cosine. Find the 5 pi over 3 and then do the work with that one. Okay, so cotangent of negative pi over 3. Okay, remember, negative, that's clockwise. We can switch that to positive. So what we can do is we can do cotangent of 5 pi over 3, right? Those are the same things. That's negative, that's positive, the same thing. And what's cotangent again? Cotangent is cosine over sine. So cosine over sine. So the cosine of 5 pi over 3, the sine of 5 pi over 3. Where do we get these numbers from? The unit circle. So go back to the unit circle and find 5 pi over 3 right there. There's our cosine and our sine, a half and negative root of 3 over 2, right? A half and negative root of 3 over 2. So it's a half divided by negative root of 3 over 2. 1/2 times the reciprocal, right? The 2's reduced down, positive times the negative is a negative, so negative 1 over root 3, right? That's if you leave the rational on the bottom. If you want to rationalize the denominator, multiply both by root of 3, and that's what you end up with, negative root of 3 over 3. Okay, so now this set of lessons also has an extra set of exercises at the end. These ones are exercise 3, special angles, and the trigonometric functions. And you can find those up in the notes section in here.